so let's go ahead and move on to section 10.3. This will be the last section that we're going to talk about regarding area and perimeter of polygons before we move into the next chapter. All right, so this last section, there's only a few slides in the notes. We are going to talk about how changing dimensions of a polygon can change the area and how it affects the area. All right, so let's take a look at the first example, right? So let's say we've got a parallelogram. All right, and we'll go with the example that's in the notes so you can kind of follow along if you want. We've got one side that's equal to a length of 12, and then we've got a height of that parallelogram, which is 9, okay? So what the example says is that if we change the height, we change one of the dimensions, either the height or the length of that side, it's going to change the area proportionally to whatever scale factor we change that dimension on. The reason being is that because the area of a parallelogram is just simply base times height. So since I'm only multiplying these two together, if I multiply one of these by a certain scale factor, then it's going to multiply the entire answer by that scale factor. Okay, so for example, if I have an area of this parallelogram, I'm going to do the base, which is 12, times the height, which is 9, all right? And then, so that's going to give me an area of 108 square units, all right? So if I was going to, let's say, double the height, okay, so let's say I want to multiply the height by a scale factor of 2, I'm going to double it. So now the height is going to be equal to 18 instead of 9. I'm going to do 12 times 9 times 2, right? So I'm doubling the height. And since I'm multiplying everything together, it doesn't really matter what I'm doing. So ultimately, it's the same as me just multiplying the entire area by 2. Okay, so if I double that, I can do 9 times 2 is 18. So now I've got 12 times 18. All right, and then that's going to simply double the total area. Okay, same thing's going to happen if I go through and I double the length of one of the sides. So if I take, or not one of the sides, but just the base. So if I double the base, so if I do 12 times 2, okay, times the height, same thing. 12 times 9 times 2, 12 times 9 times 2, I'm going to end up with the same answer. So when we are changing one dimension of a polygon, all right, by a specific scale factor, then it's going to change the entire area by that same scale factor. So if I change one of these dimensions, I multiply it by 1/3, it's going to divide the whole area by 3. If I multiply one of them by 4, it's going to multiply the entire area by 4. All right, so let's take a look at another example here. All right, so let's take a look at a triangle. All right, so if I've got a triangle and let's say I've got a base of 5 and I've got a height of 4. Okay, so area for a triangle is 1/2 base times height. Okay, so once again, if I multiply either of these dimensions by a scale factor, it's going to be the same thing as multiplying the area by that same scale factor. Okay, so for example, let's take the area of this triangle. The base is 5, the height is 4. So 1/2 times 5 times 4 is going to give me a total area of 10 square units. All right, if I double the length of the base, then it should double the total area. So let's try it. 1/2 times 5 times 2, I'm doubling the base, times 4, right? So 5 times 2 is 10, 10 times 4 is 40, 1/2 of 40 is equal to 20. And once again, it's the same as multiplying the original area by the same scale factor. and that will work with either one of those dimensions. So let's take a look at some examples where we change all the dimensions of a particular polygon. So for this example, we're just going to use a rectangle because that's a simple polygon to work with. All right, so here we've got a smaller rectangle with dimensions of 8 and 3. All right, so it's got a length of 8 and a width of 3. So what we want to do is first we want to calculate the area and the perimeter of this initial rectangle. So let's start with the perimeter. All right, so I know it's a rectangle, so if that side's 8, we know opposite sides are congruent, so that means that that one's 8 and this one's 3. All right, so we're going to double the length and double the width, right? So we do 2 times the length, and then we do 2 times the width, and we add those together. All right, so that gives us 8 times 2 plus 3 times 2. All right, so that's 16 and 6. So we have a total perimeter of 22. Okay. So our original perimeter is going to be 22, and then area, all right, is going to be length times width, right? Length times width, or 8 times 3, which is 24 square units. Okay, so there's the original area. Now what we want to do is that we want to multiply or increase all the dimensions by a particular scale factor. All right, so our scale factor we're going to say is 5, right? So this red one is going to represent our larger one. So what's going to happen is that when we scale up all the dimensions of a polygon, it's going to look exactly the same. The only difference is it's just going to grow bigger by that scale factor, right? But it should still be a similar figure. Your sides length should still be proportional as well. So let's see what happens when we do that. All right, so the length, we're going to multiply by 5. All right, so we're going to do 8, all right, times 5. All right, and then the width, we're also going to multiply by 5. All right, so that's going to be a length of 40, and that's going to have a width of 15. All right, so our new dimensions are going to be 40 by 15. All right, first we want to see, are they proportional? So let's set up a proportion real quick to show that they're proportional. So I'm going to take the corresponding side from each rectangle and set them up in a proportion. So 8 and 40, and then I'm going to set that equal to another ratio of the other corresponding sides, so 3 and 15, right? So we've got 8 and 40, those are corresponding, so I set those up in a ratio, and then 3 and 15, those are corresponding. All right, so remember for a proportion, we're going to cross multiply and then make sure that they equal the same. All right, so if we cross multiply here and we do 8 times 15, then we get a total of 120. And then we multiply 40 times 3. As you can already see, that's also going to equal 120. So when we do that, then that means that yes, they are in proportion. Okay? All right. So now we're going to see what happens to the perimeter and the area when we scale it up by a factor of 5. So first let's do the perimeter. All right, perimeter is going to be double the length. So 2 times 40 plus double the width, which is 2 times 15. Okay, so this is going to be 80 plus 30, and that's going to give us a total perimeter of 110. All right, so there's our new perimeter. All right, the original perimeter was 22, so we want to say, well, what's the relationship between those two? Well, let's take the new perimeter and then let's divide it by the original perimeter. So we'll set that up in a ratio, and we get 5. So that means this is a 5-to-1 ratio. So we took 22 and we multiplied it by 5, and we got 110. So by increasing all the dimensions by a scale factor of 5, that also increased the perimeter by a scale factor of 5. Okay, so it had the same exact effect. Now let's see what happens with the area. All right, the area, again, length times width. So we're going to do 40 times 15. All right, and that's going to give us a new area of 600. All right, our original area was 24. Okay, our new area is going to be 600 square units. Okay, so this area, all right, is what happens when we scale it up by a factor of 5. All right, when you do that, all right, it's like taking the scale factor and squaring it with the original area. So here's what I mean. So let's say that the scale factor is x. Okay, this new area is going to be 24 times our scale factor squared. Okay, so if we figure out what x is going to be, all right, this is going to be our scale factor. So our scale factor is 5. All right, so that means 24 times 25 should equal 600. And as you can see, it does. Okay, so that means that when we increase the scale factor, all right, of all the dimensions, it's the same as multiplying the perimeter by that same scale factor, and it's the same as multiplying the area by the scale factor squared, right? Because we're multiplying them, we're not adding them all together, we're multiplying dimensions together. So if you square the scale factor and multiply it by the original area, it'll give you the new area. If you just multiply the original perimeter by the scale factor itself, then that will give you the new perimeter. Okay, so in conclusion, perimeter is increased by the scale factor, area is increased by the scale factor squared. Let's take a look at an example involving a circle. All right, so here we have the black circle has a radius of 9, okay? And we are going to scale this circle, or scale the only dimension on a circle that matters, which is the radius. We're going to scale it by a factor of 1/3. Otherwise, we're going to multiply it by 1/3 or divide by 3. So by doing that, the radius of 9 becomes a radius of 3, and so that's what we're going to represent with this smaller red circle. Okay, so these two are depicting scaling this circle by a factor of 1/3. Let's see what it does to the area and the circumference. All right, so as a reminder, let's start off with the circumference. Circumference is 2 pi r. Okay, so the radius is going to be equal to 9 here. So 2 times 9 times pi, or it has a circumference of 18 pi, right? Area is pi r squared. So radius is 9, so 9 squared times pi, which equals 81 pi. Okay, so there's our circumference, and there's the area of our original circle with a with a radius of 9. All right, so now we want to scale it by a factor of 1/3, and we're going to see how it affects the circumference and the area. All right, if it sticks to the same concept of the polygons, all right, it should decrease the circumference by 1/3, and it should decrease the area by 1/3 squared. All right, so our scale factor, all right, let's write that here. All right, so our scale factor, all right, is equal to 1/3. All right, so in theory, our circumference should be multiplied by 1/3, and our area should be multiplied by the scale factor squared, right? We square the scale factor and then multiply. All right, so well, what's 1/3 squared? Well, we square the top and the bottom of the fraction, and that becomes 1/9. So our area should be multiplied by a scale factor of 1/9 because it's our scale factor squared. So let's see if that holds true when we go through and we do the calculations here. So circumference of this new circle, we scaled the radius down, so now it's 3. So circumference is going to be 2 pi r, or 6 pi. All right, our original was 18 pi. Now it's 6 pi. So did we scale 18 down by a third to get 6? Well, we take 18 divided by 3, and yes, we get 6. So that theory holds true. All right, now let's do the area. All right, it's pi r squared, so radius is now 3. So 3 squared times pi is equal to 9 pi. Our original area was 81 pi, and now it's 9 pi. So if we take 81 and we multiply it by 1/9 or divide it by 9, then we get 9 pi. Okay, so in other words, it holds true to where the circumference, which is the circle's perimeter, is multiplied by the scale factor. The area of the circle is multiplied by the scale factor squared. So if I take area of the original one and I multiply that by 1/9, then that gave us our new area, which is 9 pi, and then the circumference was 18 pi times our scale factor, and that gave us a new circumference of 6 pi. Okay? So scaling still holds true with the same concept with polygons and with circles.